Hi, you're right. So in this video, we're going to be looking at a practical investigation that we're going to be doing. Now, this is an assessable prac, which means it's going to be going towards your interim. And this video is going to help you to write out your aim, hypothesis, materials, and method. So what we're looking at in this prac is whether the speed at which a solution cools, does that have an effect on the size of the crystals that form? So we've already spoken a little bit about igneous rocks, and we've talked about how extrusive igneous rocks, these ones, are ones that cool on outside the Earth's crust. So they're cooling on the surface of the Earth. Because the surface of the Earth isn't very hot, they can cool down really quickly. This means that the crystals don't get a lot of time to form. So the crystals are going to be very small in extrusive igneous rocks. However, an intrusive igneous rock is one that cools within the Earth's crust. So we can see that one here. So within the Earth's crust, it's still very, very hot. So these rocks cool very slowly. Now, because they cool so slowly, there's more time for the crystals to form and become really, really big. So that's sort of the science behind the prac that we're doing. So we're doing an investigation to see if this is true. So I want you to think about writing your aim. So in your aim, we have to write two things: what we're going to be doing and how we're going to be doing it. In this practical, we're going to be looking at potassium nitrate solutions and forming crystals from that. So we've got potassium nitrate. So you're going to have a beaker full of that, like this. Sorry for my bad drawing. So this will be a solution of potassium nitrate. Now, when that's slightly warm, it'll be completely in solution, so there'll be no crystals visible. But as you start to cool that solution down, so we're chilling it now, you'll see that crystals start to form. Here they are. So what we're going to be looking at is how does the rate of cooling affect the size of the crystals of potassium nitrate that form. Now I want to think about our hypothesis. So the hypothesis is what your prediction is. So what do you think is going to happen? But what's really important in the hypothesis is that you give a reason why. So we're not just making a random guess, we're using some science that we've actually learned to back up our prediction. So in our experiment, we're looking at forming crystals from a saturated solution of potassium nitrate. And the way we're going to form these crystals is by cooling the solution at different rates. So your hypothesis would have to relate to if the solution is cooled quickly or cooled slowly, then the crystals would be big or they'd be small. And then give me your reason why. So why do you think this would be the case? So thinking about some of the science we've learnt in order to give me your because. What I'd like to see everybody do in this prac is highlight or underline the words if, then, and because in your hypothesis. Then you can make sure you've written, a really great hypothesis that's included all of the sections or components that you should have. All right, hey guys, so I'm going to walk through the method now. I'm not going to give you guys an actual list of all the materials, so just think about what materials I'm using as I go through this method, and you can write down your list from that. I'd also say stop this as I'm speaking to write your step-by-step method, rather than watching the whole thing through and then trying to think what I did at the start. So you're going to be given some potassium nitrate, which looks like this, and you're also going to be given a solution of potassium nitrate. So that's the potassium nitrate that you find in here dissolved into some water. Alright, the first thing that you need to do is take a test tube, and you're going to pour probably about halfway up your test tube, like that, with your potassium nitrate solution. You're then going to, I'll just put this to the side, you're going to open up your potassium nitrate and take a spatula of potassium nitrate. I'll show you what it looks like. So it looks like that, it's like a white powder. And you're going to add that to your solution of potassium nitrate. So pouring that in very carefully. There we go. Next, you're going to set up your Bunsen burner. So I haven't got all the equipment for the Bunsen here with me, but you would have your tripod, your heat-proof mat and things like that. So you carefully turn on your Bunsen burner. Then you're going to take some tongs and you're going to carefully heat this over the flame. Alright? So as soon as it starts to boil is when you can take it off. Don't hold it really, really close to the Bunsen, probably hold it a bit more up here, then you can move it in and out of the flame very carefully like that. Then put it to the side when it starts to boil and turn off your Bunsen and you can put your Bunsen away. Okay. Now the next step is we want to cool down this solution. So all of the potassium nitrate at the bottom would have dissolved by now. And we want to be able to cool it down to bring some of these, the potassium nitrate out in the form of crystals. So you're going to put half of this solution into another test tube. And that test tube you're just going to leave in your test tube rack to cool down. The other half you're going to put into another test tube, like that. Now this one you're going to put into a beaker full of ice. There we are. So put it in the ice beaker right at the side, because if you put it in the middle, you're not going to be able to see when the crystals start to form. So if we put it at the side, you'll be able to keep an eye on it and watch those crystals forming. When you're doing this, some of them might take a few minutes to form crystals, so make sure somebody in your group is keeping an eye on it. You don't want to suddenly turn around and find all the crystals have been formed and you don't know how long it took. One step I left off there is you should be timing how long the crystals take to form, and then take some photos for your results section as well. There we go.